Oh, hello. I didn't notice you there. Hi. So I've been thinking about Palette Master Element and wondering, what does Palette Master Element do and why is it even there? And what do you use it with, especially if you have a BenQ SW display? So let's find out together in this video. I'm Art Suwansang, BenQ Ambassador, and let's decode Palette Master Element. Before we start, please subscribe if you're new and hit on the notification bell so you'll be updated every time I upload a new video. Palette Master Element is a program developed by BenQ specifically to calibrate BenQ SW display line. The reason why you want to use Palette Master Element is because inside all of BenQ SW display, there is a hardware lookup table. What Palette Master Element does when you do the calibration is that it will talk directly with that hardware lookup table or that chip inside the display and do all the color adjustment at the panel level. To get Palette Master Element, simply Google Palette Master Element. Find the links that takes you to BenQ website. From there, click on the Software tab, scroll down, find the operating system that you're using, either Mac or PC, download that specific software, and then install it in your system. With a hardware calibration capable display, when you run the calibration, all of the color adjustment is done at the panel level. This means that your video card's allowed to output full signal with no tonal compression whatsoever. In essence, it's very similar to photographing a raw picture from the camera where all the information is retained and output. For software calibration, what you're really doing is you're generating an ICC profile, and that ICC profile is changing the color output from the video card, therefore compressing and expanding certain tonal ranges. What you're going to get there is very similar to a JPEG output from your camera, where some information are being thrown away and some information are being compressed or expanded in order for the color to fit in the parameter or the color space that we have chosen. When you use Palette Master Element to calibrate your display, the software is going to talk directly with the computer and the lookup table inside the display. This is something that you can't do with any other software, especially the software that come with your device manufacturer. In this case, if you buy an X-Rite device, there are two sets of software that you can use to do display calibration. One is i1 Profiler, the other one is i1 Studio. Both of those software are not capable of accessing the 3D lookup table or the computer inside the BenQ SW display. If you use the Spider software, that is the same story, where the Spider software can do a software calibration on the display. However, it cannot access the hardware calibration capability of this display. And if you're going to buy this display and not do a hardware calibration on it, it's like buying Ferrari just to drive 20 miles per hour all the time. Select device from both X-Rite and Datacolor are supported and compatible with Palette Master Element. For Datacolor, Spider 4, Spider 5, and Spider X are supported in all variation Express, Pro, and Elite. For X-Rite, i1 Display Pro is supported and is probably one of the best devices to calibrate your BenQ SW display with. However, their spectrophotometer, the i1 Pro and i1 Pro 2 are also supported as well. Right now, there's currently two new devices that X-Rite have launched. That is the X-Rite i1 Display Pro Plus and also the i1 Photo Pro 3 Plus. Those are brand new devices from X-Rite. They're currently not officially supported by Palette Master Element at this time. However, I have known people who have actually used the i1 Display Pro Plus and are able to calibrate their BenQ display successfully. The new i1 Studio from X-Rite is also supported by Palette Master Element as well, and that is a color spectrophotometer. It's the one that looks like this. If you also happen to own the previous generation of the i1 Studio, or in this case, the Color Monkey Photo, this will also work to calibrate your BenQ SW display with Palette Master Element as well. When you run the software, simply choose i1 Studio and it will work with this. Do note that if you have a Color Monkey display that is a smaller device, or the new i1 Display Studio, both of those devices are not compatible with Palette Master Element. I have released a few videos on how to calibrate your BenQ display with Palette Master Element. And many of you have watched both videos and are wondering which is the best setting because it seems as if I'm giving you conflicting information regarding the settings to use. In this case, I'm going to give you a definitive guide on what setting to use here with Palette Master Element. The first setting that I'm going to show you is going to be the best setting possible if you can get the validation to work. If you can't, then go ahead and revert to the second setting that I'm going to show you later on. So let's start with the first setting. I'm going to choose Advanced for my calibration, choose Profiling, and within this screen, what I'm going to do is change the RGB primary from Adobe RGB here to Panel Native. When we are calibrating our display to panel native RGB primary, what we are doing is using the widest color gamut that this display can produce. And from my testing, this color gamut is generally going to surpass Adobe RGB by about 3 to 5% at the very minimum. From there, come in and choose the luminance value that you want to set. In this case, anywhere between 80 to 120 candela is a good value. Something to keep in mind is that generally I keep them in 10 intervals, for example 80, 90, 100, and 120. You can dial in 95 or 85 or something like that, but to be honest with you, our eyes can't really discern those 5 candela differences between all the other different settings. Gamma, go ahead and leave it at 2.2 because we're doing photography. Black point, the best thing to do with black point on these IPS LED panel is to set them to relative. This means that the black is going to scale relative to the white point of the brightest part of the display rather than trying to set it to absolute black, forcing it to go darker in the black tones. So in this case, relative is going to be best. You can go ahead and leave the mode on XY. That's not going to do anything much at all if you change it to UV, so go ahead and leave that on XY. Click on Next. Now we're at this screen. A couple things to note here is that all of the BenQ displays come with multiple calibration slots. Depending on which BenQ you have, some of them will have 2 calibration slots, some will have 3. In this case, the display that I have with me is the SW321C, and this one has 3 calibration slots, or 3 hardware calibration slots. In this case, I can choose to use whichever one I want to use it to, and you can actually have these hardware calibration slots work with multiple computers too. For instance, calibration 1 can be for your desktop, calibration 2 can be for your laptop, and calibration 3 can be for your Windows PC, for instance. That's just an idea. On a Macintosh system, the profile distribution system level is always going to be grayed out, especially if you run in the last version release of the Mac operating system. And part of this is because Apple is sandboxing you. When you check system level, what that's going to do is distribute a profile system-wide at the root level. This way, other people that use the computer can also use this calibration that you just made. There is a way around that if you're using Macintosh in a multi-user environment. For Windows users, if you're using in a multi-user environment, go ahead and check on system level distribution and you should be good on that one. Next up, profile version. For Mac, you can go ahead and leave it at version 4. For Windows user, go ahead and change the profile version to 2. This way there is no conflict between the profile that it's producing and the Windows operating system. Profile type, we're going to change this in this one from matrix to 16-bit LUT. This is going to provide us with the best result and the best ICC profile build type. Patch size, go ahead and choose large because we're measuring more colors on this one. From there, go ahead and start measurement. Once you're done with this measurement, go ahead and validate the calibration and make sure that it passed. If your validation passed with good values, delta E under 2, you're set and ready to go. Now, for instance, if this setting fails, there is another setting that you can use, and this is my secondary backup method. And the reason why I'm recommending this as a secondary method is because this is the vanilla version of calibration that it will generally always work. And when it doesn't, it usually indicates that there is a greater problem going on there. Many times it's not the problem with the display. I've been helping BenQ customers all over the world, and I found out that a lot of times it has to do with our operating system. But we'll talk more about that later. Let's go and take a look at the settings here that we need to use in this case. So for this secondary method, we are still going to use the advanced method of calibration, profiling, and in here we're going to leave the RGB primary at Adobe RGB. The luminance, go ahead and again set this anywhere between 80 to 120 depending on your choice. Gamma, go ahead and leave it at 2.2. Black point in this case, because we're still using an IPS panel, I still recommend setting it to relative. I know some users are going to find absolute better, so that's going to be your choice in this case, but my recommendation is to go with relative. Again, mode XYUV, that's not really going to change the outcome much. From there, go ahead and click next. In this screen, you can come in and choose the hardware calibration slot that you want to use for this calibration. You can change the profile name if necessary. And on a Windows system, you can choose system level or check that box in order for the profile to be installed at the root level. This way, other users that are using the system can access this profile too. If you're on Mac, go ahead and leave it version 4. For Windows, change that to version 2. This way it doesn't conflict with the operating system. Profile type, go ahead and choose matrix for this one. Patch size setting, leave it at large or change it to large if it's not set to large already. From there, click Start Measurement. At this point, because this is the vanilla setting, the calibration and validation should pass in this case. If for some reason the validation does not pass, that's usually an indicator that something is actually going on with your operating system. Many times what I found is that when the validation does not pass, it's really nothing to do with the display, but rather the computer operating system. So for instance, if you have been upgrading from multiple different versions of OS in place, that means you're not doing a clean install. Sometimes a lot of the files that are unnecessary or a lot of this conflicting file from previous generation operating system could still be in your system. Or for instance, if you got a brand new laptop and you restore it from a backup, that generally could cause problems too at times. So that's just something to keep in mind. On a Mac system, what you can do is simply just create a separate container on your SSD and install a fresh copy of your operating system. Then install Palette Master Element and try to calibrate the display using Panel Native again. Most of the time, I found out that this will pass validation without any issues. One last thing I want to cover here is in the previous screen. So for instance, if you're unlike me and you don't want to use Panel Native or you don't want to use Adobe RGB in its case, there are different color spaces that you can still come and set your RGB primary to. sRGB, if you want to choose to work in sRGB color gamut. Rec 709 if you're doing video editing. DCI-P3 if you're doing work and content specifically for Apple devices. These are just something to think about. And there's also a custom mode where you can come in and dial in the RGB primary of the gamut. But we're going to go ahead and not use that in this case. In BenQ Palette Master Element, when you run a calibration, you can choose different RGB primary. One of the most common questions I get asked is, why do we choose different one? Well, in this case, because we have a hardware calibrated display, this is where the magic comes in. If you choose Panel Native, you're using the maximum color gamut that this panel can produce. The thing is that if you go down to Adobe RGB, you're defining the color gamut so that it would fit into Adobe RGB. If you want to work in a color gamut space, you would choose sRGB, so on and so forth, depending on your workflow and needs. But the nice thing about having a hardware calibrated display is that you can constantly come in and calibrate the display and change these color gamut as necessary depending on your workflow and need. This is something that you can't do with a software calibrated display or a display that is not capable of hardware calibration. Because once that display has been calibrated from the factory, let's say it's been calibrated from the factory at DCI-P3, you're pretty much locked into it. It doesn't really matter if you use an X-Rite software or the Data Color Spider software in that case to calibrate those software display. What you're really doing is that you're adjusting the color based on the DCI-P3 calibrated color space from the factory. And there's really no way to change the RGB primary. And this is where the SW series display with the hardware calibration and Palette Master Element shines. I've mentioned before that you should always validate your calibration after it is done calibrating. This way you can guarantee that the colors that is showing through the display is accurate and is within range and within the delta E tolerances. For this display, BenQ have guaranteed that the average delta E is always going to be less than 2. So in general, if you pass the validation with Palette Master Element, you're set. If for some reason you don't pass, like I said before, this is a good indicator that there is something going on in the system. Many times you can try to install and uninstall a program, but that won't do much. The next thing that I would do in this case, that if you don't want to go in and reinstall or reformat the operating system yet, is to do a few things. Number one, check and make sure that you are not using an HDMI cable. Now, some people have been able to successfully calibrate their display with HDMI, but there are many others that failed with HDMI. So make sure that if you can use DisplayPort or USB Type-C or some adapter that converts the USB Type-C signal into a DisplayPort, that will probably be the best cable or the best connector to use in this case. Once you have done that, the next thing that I would do is probably use my vanilla setting to calibrate your display with Palette Master Element as I've shown earlier. And lastly, what I would do in this case is to do an A/B testing. There's a few ways to do this. For instance, you can hook up another computer to the display and try to run the calibration with Palette Master Element and see if that fails or not. If that passes, it's usually a great indicator that there is something going on in the operating system of the computer that you're trying to originally calibrate your BenQ display with. If you're still getting calibration fail, make sure that you're running on the latest version of Palette Master Element. You can go ahead and launch Palette Master Element up and it will automatically detect for a new version, or you can simply download it directly from BenQ website. As of this filming, the current version of Palette Master Element is 1.3.8 for both Mac and PC. There's one known bug in Palette Master Element, and it has to do with the ICC profile that it generates. If you calibrate your display with Palette Master Element and you use any other RGB primary other than panel native, this issue will show up. The issue manifests itself in Lightroom when you go from library to develop module. If you have the graphic card selected and is using graphic rendering, you will see that the color becomes oversaturated. I have made a guide on how to solve that problem by disabling the graphic card. In Photoshop, it will happen the same way when you use Camera Raw to open up a photo. Within the Photoshop interface itself, you should be able to use it without any of these issues. The other issue too is that with 1.3.8 on Windows, we have some issues where the calibration will pass just fine. However, the hue of the red may not be looking correctly on your display. In this case, the best thing to do is to wait for another release, or if you can get your hands on the previous release of Palette Master Element, you can also try that as well. Something to note though is that if you go back to any version before 1.3.8, calibrating using panel native and 16-bit LUT may not work because that has been a bug in the past, and that's also the reason why I've actually not shared that method until recent. One last bit of information here, and this is one of the more frequent questions that I receive about Palette Master Element as well, and that is the ICC profile. So many of you out there believe that once you do a hardware calibration on the display that there won't be an ICC profile that sits on your system. The answer to that is somewhat incorrect, and you will still have an ICC profile that sits on your system because your system will still need to reference some sort or some form of ICC profile. In this case, the ICC profile that Palette Master Element generates is one that tells your video card to output all the colors at maximum value. There is no tonal compression or tonal or color changes going on with this ICC profile. Here's my thought on Palette Master Element. I think that BenQ right now is going through a lot of growing pains with Palette Master Element software. They've literally gone from a manufacturer that made literally just one model of SW to now making over 5 different models of SW and distributing worldwide to use on 2 different operating systems. There are going to be some issue that crops up. What they have been doing is that they have been constantly fixing their software, and they're working to improve Palette Master Element as they go along. And so far, I have seen this improvement in Palette Master Element where there are less bugs as we go through with their new releases. So that's something to keep in mind. Personally, I still think that Palette Master Element is the best software to use to calibrate your BenQ display for a few reasons. Number one, it's included with your display for free. And secondly, it taps one of the greatest potential of your SW display, and that is the hardware calibration chip within your display. Without Palette Master Element, you would not be able to access that in majority of SW models. So that's just something to keep in mind. So I hope that you find this explanation on Palette Master Element helpful and demystify a lot of questions that you may have about Palette Master Element, what it does, and what's the benefit of using Palette Master Element when you have a BenQ SW display. If you have any further questions, please feel free to leave them in the comment section below. Please give this video a like if you find it helpful. Subscribe to my channel if you're new. Hit on the notification bell so you'll be updated every time I upload a new video. And until next time, ArtIsRight.